Hi guys, welcome to our community Codeco. In this tutorial, we are going to see architecture of Intel 8085 microprocessor. So this is the architecture we are going to discuss. First, we will see what are all the components present in microprocessor, and then we will discuss about each and every component. Okay, let's start today's tutorial. Microprocessor components: control unit controls microprocessor operations, and ALU, which performs data processing function, and registers provide storage internal to CPU and interrupts internal database. See, now we will see in architecture. Okay, so you are able to see, right? This is control unit or timing and control. This is ALU, this is one component, and this is another component which is ALU, which performs arithmetical and logical operations. This is we are going to call as arithmetic logical unit. This is another component. This is 8-bit component. Okay, and then registers. These are all the registers, different types of registers. Okay, we are going to discuss about each and every register within few slides. Okay. And then we have few more components: serial input-output control, internal data bus, and interrupts control, and address buffer, and data address buffer. At the end, we are going to have address bus and address data bus. Okay, let's start knowing about each and every component. Let's start with timing and control unit, which is nothing but control unit. It provides timing and control signal to the microprocessor to perform operations. Okay. The main purpose of control unit is to provide timing and control to microprocessor. How it works and what is the control to work and which time it have to work. So these are all the few timing and control signals I had given here. You are able to see, right? Control signals: ready, RD bar, W bar, ALE, and status signals S0, S1, IO/M, and DMA signals HOLD and HLD, and reset signals rest in, rest out. Now take a look in architecture. See, you are able to see, right? Now we have discussed about this component in architecture of 8085 microprocessor. Here you are able to see reset. In this we have two another components: reset in, reset out, and DMA in this HOLD and HLD. And we are going to have status S0, S1, and control ready, RD bar, WR bar, ALE. Okay. Now we'll see another component, ALU. Okay. ALU is nothing but arithmetic and logical unit. As the name suggests, it performs arithmetic and logical operations like addition, subtraction, AND operation, and OR operation, etc. See, we had discussed about control unit. Now we are discussing about ALU. Here, the all arithmetical and logical operations is going to be happen. After while doing arithmetic and logical operations, it have to store the values, right? And at the end, when we get the result, it have to store the result. At this time, we are going to use registers. Okay. Now take a look into registers. Registers are two types: general purpose registers and special purpose registers. See, these are all four belongs to special purpose registers, and these all belongs to general purpose registers. Now take a look into general purpose registers. General purpose registers are B, C, D, E, H, and L. You are able to see here, right? These are all 8-bit registers. When we are performing singly, if we are performing with a B register, then it's going to be 8-bit. If we want to work with 16-bit registers, then we have to pair them. How we are going to pair them? We are going to work with B and C registers, and then D and E registers, and then H and L registers. Okay. So this is all about general purpose registers. Now we will see special purpose registers. Special purpose registers are four types: accumulator, it is 8-bit register, and then temporary register, it is also 8-bit register, and flag register, also known as flag flip-flops resistor. It is also 8-bit resistor, but you are able to see here 5, right? So which says that we are going to use only 5 bits data. We are not going to use 8 bits, but you are able to see 8 in everywhere up to now we have discussed, except flag flip-flops, because here we are going to use 5 bits only, and instruction register. It is also a 8-bit resistor. Okay. Now take a look into accumulator and temporary resistor. Accumulator is a 8-bit resistor used to perform arithmetic, logical, input-output and load store operations. It is connected to internal data bus and ALU. Okay. See, now you are able to see here we are discussing about accumulator, right? So it's going to store the data after performing each and every operation. Okay. You are able to see, as I said, it connected to ALU, right? See, this is the accumulator we are discussing and connected to ALU, and it is connected to internal data bus. So this is the internal data bus. Okay. Now take a look on into temporary resistor. It is an 8-bit resistor which holds the temporary data of arithmetic and logical operations. When we are performing with arithmetical and logical operations, you are able to see this is also connected with ALU and internal database. See, here we are going to store our temporary variables or values when we are working with our operations. Okay. Now we will see flip-flops or flag resistor. Flag resistor divided into few components or few types. Flag resistor is also 8-bit resistor, shows the status of the microprocessor before and after an operation. See, up to now we had discussed about accumulator and temporary resistor which stores the data, but it's going to be flag operation or flag resistor is going to say the status of the microprocessor when it's going to be saved both before and after an operation. It's divided into few types. Signal resistor, you are able to see S, D7 signal resistor, and then Z zero flag, signal flag and zero flag, and then AC auxiliary carry flag, and then parity flag, and then carry flag. Okay. Now take a look into signal flag. Signal flag used to indicating the signal of the data in an accumulator. We are going to store something in our accumulator at the end of the operation, right? So it's going to be show this signal or okay. The signal flag is set if negative. If negative numbers is going to be stored there and it's going to be written as output, then you are going to show as 1 output. And the signal flag is reset if positive. So if positive numbers are going to be written, then it's going to be shown as 0. Okay. Now we will see 0 flag is set if result obtained after an operation is 0. So if we are not going to get any positive number or negative number, exactly we are going to get 0 means it's going to be shown as 0 flag. It's set following an increment or decrement operation of that resistor. Okay. Now we will see auxiliary carry flag and parity flag. Sorry guys. Auxiliary carry flag is set if there is an carry out of bit 3. Okay. So if we are going to have any carry when we are performing with operations, then we are going to work with auxiliary carry flag and parity flag. It's set if parity is even. You know, right? When we are going to say parity is even, when we are going to get continuously once is even, then it's going to be even parity. If we are going to get continuous odd number of ones, then it's going to be odd parity, right? So if we are going to get even parity or odd parity of ones continuously, then we are going to show parity flag. Now we'll see instruction register and decoder. See, we have discussed about flag flip-flops, temporary resistor, and arithmetic accumulator, and then arithmetic logical unit, and then control unit. Now we are going to discuss instruction register and instruction decoder and encoder. Now I am discussing about that instruction register and decoder. It is an 8-bit register. When an instruction is fetched from memory, then it is stored in the instruction register. instruction decoder decodes the information present in the instruction register. So what here instruction register is going to be work? It's going to be fetching data from memory. After fetching the data from memory, what's the instruction decoder and mission cycle encoding doing here? It's going to be decodes the information present in the instruction register. Okay. Now you'll see program counter. You are able to see here, right? Program counter. We had discussed about resistors and then ALU and then control unit. Now we are going to see program counter. It is a 16-bit register. See, up to now we have discussed about 8-bit registers. This is a 16-bit register. You are able to see 3 are there 16-bit registers. One is stack pointer and program counter and increment decrement address latch. Okay. Now we are seeing program counter. It is a 16-bit register. Use it to store the memory address location of the next instruction to be executed. So what we are going to store here, it have to perform some logical or any operation, right? After performing something. So what it have to do next, that's going to be stored here. Microprocessor increments the program whenever an instruction is being executed, so that the program counter point to the memory address of the next instruction that is going to be executed. Okay. So now here microprocessor is going to be increments. Or why it's going to be increments? Whenever an instruction is being executed. After completion of the execution, the microprocessor is going to be increments the value. Okay. Now this is stack point. It is a 16-bit register. Works like stack, which is allows incremented, decremented by 2. Okay. During when it's going to be incremented, decrement, when we are working with push and pop operations. You are able to see here, right? Stack pointer. Everyone knows, right? What is stack? Last in, first out. So that's why here what is nothing but stack pointer is nothing but always points the top of the stack. Okay. That's why we are calling it a stack pointer. And then interrupt control. As the name suggests, it controls the interrupts during a process. When a microprocessor is executing a main program and whenever an interrupt occurs, the microprocessor shifts the control from the main program to process the incoming request. After the request is completed, the control goes back to the main program. Here you are able to see, right? So this is interrupt control. So when a signal is going, see, it's performing some operation. This whole thing is performing some operation, but I want to stop the current operation. I want to perform another operation or another thing. Then I am going to say to the interrupter, and the interrupter going to say stop the present function and first work with another function. After completing the another function, it's going back to previous function. Okay. So that is how interrupt works. It's going to stop the current function and going to give another function. Okay. That's the meaning of this. And we are going to have 5 interrupt signals in 8085 microprocessor. INTR, RST 7.5, RST 6.5, RST 5.5, trap. Okay. You are able to see here, right? INTR, INTA bar. We will discuss in another tutorial. Okay. About inner components. And RST 5.5, RST 6.5, RST 7.5 and trap. Okay. Now we will see serial input output control. It controls the serial data communicating by using these 2 instructions. SID serial input data and SOD serial output data. You are able to see here, right? It's going to control the input output data. Using which things? SOD and SID. SOD stands for serial output data and SID stands for serial input data. Okay. We have only few components: address buffer and address data buffer. This is address buffer and this is address data buffer. The content stored in the stack pointer and program counter is loaded into the address buffer and address data buffer to communicate with the CPU. Okay, see, we are going to store something in stack pointer and program counter, right? So this we are going to call through address buffer and data's address buffer. Why we are calling here data present in here? We are going to talk with CPU. The memory and I/O chips are connected to be used. Connected to these buses. The CPU can exchange the desired data with the memory and I/O chips. Okay. Now we'll talk with address bus and data bus. Data bus carries the data to be stored. It is bidirectional, whereas address bus carries the location to where it should be stored, and it is unidirectional. It is easy to transfer the data and address input/output devices. See what we are talking about: address bus and address data bus. And data bus is going to be stored data. Okay, this is data bus, and here we are going to store data, and it is bidirectional. If it want to go to address, it will go. If it want to go to data, it will go. Okay, but here address bus is bidirectional or unidirectional, which means it will go through only address. It cannot retrieve any data. Okay, that's it for this section. Have a nice day.